right, there we go. All right, so I think I've talked, at least in my classes, we've talked about this thing called an imaginary number. And I told you that this year we would be learning about them. So in my class, we talked about how possibly in middle school, sometimes teachers don't always say the best things, honestly. If they asked you, hey, can I take the square root of a negative number? And hopefully your teacher didn't say no. Hopefully they said more of a not right now, because that's the better answer. In middle school and Algebra 1, you do not learn how to take the square root of a negative number because it's not a real number. So this is not real, which is all the numbers that you have studied so far. This year, we're actually going to go into a number system called the imaginary numbers, and that's where square roots of negative numbers, that's how imaginary numbers are kind of made. So first off, let's go over some stuff. If I ask you, what is the square root of 9? What is the answer?
3.
3.
Perfect. The answer is 3. If I asked you x squared equals 9, what you're going to do is you're going to do this process called isolation. The reason we can do isolation is because we only have one type of x. Notice in the example that I'm about to finish down here, oh yeah, you should be seeing something.
I don't think you're sharing your screen.
Perfect. There we go. So many buttons to click, so little time. So if I asked you for the square root of 9, like you guys said, it would be 3. But if I asked you to find x squared equals 9, that's a little bit of a different process because I'm asking you what numbers times itself equals 9. And what we can do is call this thing called isolation, but I'm trying to show you why we can do isolation here and why we can't do isolation down here, which is kind of what we ended on last chapter. Does anyone remember why we can't do isolation here, but why we can do isolation in this problem?
There's 2 different x's.
There are 2 different types of x's, exactly. Since there's 2 different types of x's, we can never ever combine them because they're not like terms, which means I can't make this say x equals, which is called isolation. Okay? Instead, what did we have to do to solve this problem? What did we have to do to solve this?
Factor.
Yeah, we had to solve this by factoring. That's why that factoring word came up. So when you have 2 different types of x's, you can't do isolation. But if we look at the example we're about to do, how many different types of x's do we have up there? Someone besides Orister, come on. Orist, sorry. How many types of x's do we have here, guys? Come on.
1.
I think you said, did you say 4, Kelly?
I said 1.
Oh, you said 1, it sounded like 4. Yeah, we only have one type of x, which means we can isolate the x, which means get it by itself. Normally, if I have kids in class and I know one of the kids well, I would tell them, oh, we're going to isolate x just like so-and-so is on the weekends, all alone, just kind of messing around. But so we're going to get this x so where it's all by itself. So how can I, like if I had x plus 3, you would minus 3, right? The opposite of it. If I had 2x, I would divide by 2 because you're getting the x by itself. So you're doing the opposite of whatever you see. So what do we see in this example? What is being done to x?
We're going to take the square root.
Well, we're squaring it right here, yes. So to undo that, we would square root it. And so what would be our answer? X.
3.
So it is not actually 3. You have half the answer, Kelly. The actual
Is it positive and negative?
It is positive or negative. It is plus or minus 3. Now, some of you, I hope, are going, wait, Mr. Martin, you legit just told us that the square root of 9 is 3, yet over here, when we did it, the square root of 9 became plus or minus. How do I know the difference? I hope you're asking yourself that question. Well, the answer is whenever someone else asks you what the square root of a number is, so if I say, hey, what's the square root of 25? The answer is just the positive answer, just 5. But if you remember, this question started off with no square root in it. There's no square root in this problem to begin with. We put a square root in to undo squaring. Whenever you put the square root in, that's when that plus or minus sign must pop up. Does that make sense to everyone?
Yep.
So if I said, what's the square root of 36? Your answer should be? If I need to start calling you out, I can.
6.
Thank you, Taylor. I appreciate it. Yes, it is 6. But if I said x squared equals 6 or 36, Nina, what would your answer be?
Plus or minus 6.
Yes, because you would be putting the square root sign in to undo that. I'm telling you, my college professor, because by the time you get to, I took Algebra 2 pretty young, and then I kept going through math, and almost every time I saw a square root, I was undoing something to get to it. So my college professor put like this problem up on the board, and from what I remember in college, every one of us put this as the answer. Because we were so used to doing that, and he, pointed out to us that that is the wrong answer. That when you have the square root of 100, the answer is just 10. And he was showing us different things because no teacher ever pointed that out to us. And so we just kept getting used to seeing this problem because we were used to doing algebra. And so all the time we saw a square root, we put a plus or minus sign. Well, you need to know when it's appropriate. When you put it in there, you put the plus or minus. When it's already part of the original problem, no plus or minus. All right, so that will be used. That's something that we're going to do in this section. Some other things I want to go over is I like to go over the Algebra 1 because I know that we don't know it the way we possibly or probably should, all of us. So I like to go over some stuff that's going to come up in this chapter. So like the square root of 2 times the square root of 3. Does anyone know what that you can do with that? How you can simplify that? Well, if you have the same thing, you have this, go ahead. What do you think it is? It's okay if you're wrong, by the way.
I was gonna say, wouldn't it be the square root of 5? I mean 6.
Yes. When you have the same radical, which means this is a square root and this is a square root, by the way, in Algebra 2, we will deal with different radicals. We'll deal with this kind of thing. As long as both their radicals have the same, we'll talk about what this number is later on. But as long as they have that same number there, we'll define it in a couple chapters, I think. As long as they have the same number here, you can actually multiply them. Does that make sense? So this actually becomes the cube root of 6, too. But if I had the square root of 2 times the cube root of 3, you cannot combine those yet. That would be as simple as you can do right now. I'm actually going to teach you how to deal with that in Algebra 2. That's one of our chapters that we go over. And then the thing that sucks about math, if I'm being honest with you, is what does the square root of 2 plus the square root of 3 become?
Square root of 5.
It doesn't. It doesn't. Actually, this is more like if I had 5x plus 5y. Whenever you do addition, in order for you to add things together, they have to be the same. So like, you know that 5x plus 5y can't combine because they're not like terms. So this is like me saying I have 1 square root of 2. I have 1 square root of 3. What do I have? You have 1 square root of 2 and you have 1 square root of 3. They can't combine. However, if I had, let's say 2 square roots of 2 and I added 3 square roots of 2, now I can say I have 5 square roots of 2 because I have 2 of them here. I have 3 more of them. I have 5 total. Oops, square roots of 2, sorry. I have 5 square roots of 2 because they're the same identical thing. In math, I'm telling you that it is tricky, right? So if I have 2 square roots of 2, and I add 3 cube roots of 2, again, I can't add those together because these are square roots of 2. That's cube roots of 2. These are not like terms. That would be as simple as I can get that. So it's about identifying these kind of look like little tiny things, but they may make huge differences in math. So you got to know the rules of what we can and can't do. So we can't apply multiplication rules, which says this can become square root of 6. We can't apply those to addition. There's nothing more I can do here. Got to see the difference between these two. And it all has to do with this stupid little sign that's in between them. And that stupid little sign makes a huge difference in math. And I think that in a lot of times when kids get to Algebra 2, they haven't been paying attention to these little details because when you're in Algebra 1, you're only dealing with this for a whole section, and we never mix the two up. And then all of a sudden we're in Algebra 2, and all this stuff is thrown together, and we mix it up, and we don't remember the rules. And that's why Algebra 2, I think, is, in my opinion, the hardest math course in high school. But once you kind of get through it and you start to realize, oh, I need to pay attention to those little details, math starts becoming easier, I think. So why am I talking about this? Because we're going to talk about this thing called I, and it's an imaginary number. And anytime you see the square root of -1, that equals I. So if I asked you to do this, x squared equals 9, -9, sorry. And you guys should be taking notes right along with me. This is very similar to what we did before. How do I undo squaring something?
Raise it to the second power.
It's already raised to the second power. How do I undo that?
Oh,
You
square
take
root.
the
Did I
square
say
root.
square? Did I say square root for Orist? That's my fault if I did. How do I undo
I'm
squaring
not
something?
sure.
So we square root it. Does everybody understand that? So x,
And then, is it plus or minus?
it's going to definitely be plus or minus. Very good, for sure. And then what I think of this is, remember how I told you, if you have the square root of 2 times the square root of 3, you can make that become the square root of 6. Well, if I see the square root of 6, I can actually make that. It might not help me, but I can make it become the square root of 2 times the square root of 3. What does that mean I can do with the square root of -9? I can make it the square root of 9 times the square root of -1. And if I think of it like that, what's the square root of 9?
3.
And someone besides Orist, what's the square root of -1? What did I just define it as?
I.
So there's my answer, plus or minus 3i. And that stands for an imaginary number. Are there any questions on that so far? As soon as I see a square root of a negative, what do you think I pull out right away? Like if I saw x squared equals -25, again, I'm doing easy ones in the beginning because they all have perfect squares. They won't all tomorrow, but we'll talk about that tomorrow. X equals, as soon as I see I put the square root, I put plus or minus. As soon as I see a negative, I throw down an I, and then when I have a square root of 25, that's 5. But anytime I see a square root with a negative, I know I'm going to have an I pulled out. I is going to be part of the answer. All right, what if I had this? I'll do it easy. Does that work out? Hold on, I might have screwed up. Oh, I messed up. Let me change this number. Yeah, that should work. Okay, what process can I use? Do I have to solve this by factoring? kind of trying to tie it all together. Am I going to solve this by factoring? Am I going to do this by isolation, and why?
Isolation.
Why would I do isolation?
Because there's only one type of x.
So there's one type of x. I can move all this other crap. I can move this away, I can move this away, and I can move this away. But the problem is I got to move it in the right order, right? So what I'm doing is I'm actually going to be working backwards on PEMDAS because I'm undoing it. So I'm going to get rid of my addition and subtraction first. So I'm going to minus 12. And then I'm going to get 2x squared equals negative 8. Okay, now I'm going to work on multiplication or division. So I'm going to divide by 2. X squared equals negative 4. Then I'm going to square root it. Square root. Who put the square root sign in? Who put the square root sign in there? Okay, the answer is we did. So what does that mean? Why am I talking about that? What do we have to put down here?
Plus or minus.
Very good. Plus or minus. As soon as I see the negative, what do I know is going to be part of my answer?
I.
And then what's the square root of 4?
2.
So does everybody
2.
understand how I got that answer? You can raise your hand in the middle of if you want to get my attention too, so that I stop and answer any questions that you have. All right. Next, combine these things. Like if I have a negative 8 plus 4i plus 6 minus 10i. Well, again, the most important thing is to know my rules. And there's this thing called the associative property that says, hey, if you have 2 plus 3 plus 4, you can actually put parentheses in. As long as it's all addition. Or I think of it as all addition, kind of like I think of this as a plus and negative 10i. So if I can put parentheses in, what does that mean I can do?
Take them out.
So right here, because this plus sign right here, I can actually take them out. If that plus sign wasn't there, then what am I supposed to do with these two bubbles?
Distribute.
Yes, and that's a totally different process, right? So since this is a plus sign here, I can actually think of this as a negative 8 plus 4i plus 6 minus 10i. And then I go, hey, a negative 8 and a positive 6 can combine, and that gets me with a negative 2. A positive 4i and negative 10i, those are like terms, leaves me with negative 6i. And that would be my final answer for that question. Does that make sense?
Yep.
Try this one on your own. Try that one on your own real quick, on your own piece of paper. Anyone brave want to tell me what they got?
I can.
Okay, what'd you get?
I got negative 6 minus 8i.
Perfect. So what you hopefully did was you went negative 16 minus 3i plus 10 minus 5i. This and this combined to make a negative 6. This and this combined to make a negative 8i. And that would be your answer. Questions on that so far? Now, something I didn't cover is what this is actually called. This is called a complex number. There are two parts to this number. This part right here is what we call the real part. This right here is what we call the imaginary part. Because there's both of them together, we call it complex. So actually, you can tell your parents finally that math is really complex. You actually have the reason to tell them this math is very complex. So this is called a complex number, real part, imaginary part. If I asked you what kind of number this is, what kind of number is that? What is 5i, guys?
Is it still a complex number?
It's imaginary. What is the number 10?
Real.
And if I said 10 plus 5i, it's now a?
Complex.
That's it. That's it. All right. I'm getting a little bit ahead, but that's okay. All right, what's the difference on this one? And actually, I cannot drop my parentheses right away on this one. Again, these are the little rules, little things that kind of suck about math, but we got to deal with them. What's the difference here?
We're subtracting.
So what do I have to do with the subtraction sign before I can actually go ahead and drop my parentheses? Anyone know?
Distribute.
Do we distribute it?
Yeah, we're going to distribute it. And all that's going to do is do what to each one of those numbers behind them?
Change the sign to positive and negative.
Right, so this is a -5, so it's going to become a +5. This is a positive 6i, so it's going to become a -6i. Notice, once I distributed, I could drop my parentheses, and then I think what we did before, a -10 and a +5 is a -5. A +5i and a -6i would be a -i. We don't write one I, just like we don't write one X, we just write I. Whenever you see I, it just stands for one I. So you won't see it written like that. You'll see it written like that. That's a little bit ahead of what I did in all my other classes, so I might talk about that again tomorrow. But as far as that, is there any questions that we have as far as the class or anything I went over today in class? There will be homework tonight.
You said like the homework assignments are going to be on focus, right?
Yes, there will be. Yep, they will be there. You'll see tonight. It'll say a new assignment. It'll say 2.4, and then when you take your mouse like this and hover over the name of it, a little gray box will appear that has notes, and it will tell you what numbers you're supposed to do in those notes.
All right, thank you.
And then it is expected that you turn in it is due before the class period. So you must have that uploaded before you come to class. It is not due at the end of the day. It is due just like my face-to-face kids when it comes to class. So it is due at the beginning. Other than that, anybody have any other questions? We're about a minute out. Again, I hope you feel free to ask me any questions at any time. Feel free to stop me if you're going, Mr.